Hello and welcome to Tech 5, 5 technology stories that I think you should know about. Who am I? I'm Sean Thuris, a software developer in the San Francisco Bay Area where I run a small technology consultancy. Story number 1. SpinLaunch. This is a rocket launcher. Although it looks like some sort of advanced farm equipment, it actually spins a rocket on the end of this arm that you see rotating here and holds the satellite at the end of that arm, and then it shoots it out the top, just like that. As you can see, it's not flipping end over end, as you might expect it to. But you do see that when it comes out, it doesn't come out straight either. So a lot of people have critiqued or criticized or expressed doubts about this, the viability of this, such as John Carmack, who's an engineer as well as being the developer of Wolfenstein, Doom, and Quake. So let's say you have this projectile that you want to send up into space. Inside it is 2 stages of propellant, and then whatever payload that you want to deliver. It's pretty small. I'll show you here. So it all has to fit in this little projectile. So let's say this is going around like this at a high speed, and let's assume that it's being held by the center of gravity. If it's let go here, it's going to slam into the side of the thing. If it's let go at the top, it's going to hit here. So if it's let go just at the right spot, maybe here, it's going to go up, but it will already be at a slight tilt. And because it has these fins, these vanes, to stabilize it, so when it comes in contact with the air, it's going to straighten out. The whole thing is in a vacuum, so it can't be a hard vacuum because this thing punches through what looks like a piece of plastic here. One of the critiques that people had of this design is that when the projectile is let go, whatever is on the other end of the arm, whatever was balancing it, is now out of balance. And if you've ever had to run in and stop a washing machine from walking across the floor, you know that this could be a problem. In their patent, they allow for the possibility that they might release a weight at the same time that they release the missile from the top. They release a weight into, say, a pool of water or something at the bottom. And that could, if they were done exactly at the same time, that could keep it balanced. Another thing they could do, if there were a small weight on the same side as the missile, that at the moment the missile is released, the weight could slide out and serve to balance that. But that sounds dangerous. In any case, they're confident that they have something that's going to work. But the critique here is that even if they're able to send these projectiles into the atmosphere high enough that they save lots of propellant, well, really, is it worth building this entire system just for that? Especially because it means that the satellites they can send up are going to be very small. Anyway, it's an interesting technology that I hadn't heard anything about before, and there you go. Now, why does cannabis smell like skunk? Some scientists have discovered that the skunky smell of cannabis is not related to the terpenes in the plant that people assumed it was. Terpenes are turpentine and other organic compounds. Actually, there's a terpene called squalene that's the building block or the precursor to human steroids. In any case, the scientists looked into whether the peculiar smell of cannabis might be related to the sulfurous compounds in garlic and in skunks. So they had to build their own special measuring equipment for this. And indeed, they discovered that there are volatile sulfur compounds in cannabis, very similar, as you can see, to the ones in garlic. These allyl compounds. That's allicin that you may have heard about as a dietary supplement. And these thiols are found in our friend the skunk, as you can see. It's possible that these compounds might have some kind of health benefit. Story number 3. Stay with me on this one. The headline is a little bit confusing. Dual criticality for China's HTRPM. China is building some nuclear fission plants based on a different type of design from the typical one. And this Shidawan reactor, there are 2 of them. They built them side by side. They use something called a Pebble bed, which I will explain in just a minute. And it's cooled with helium in the sense that helium is used to transfer the heat from the fuel to the turbine rather than using water and steam. So what is the Pebble bed? There are billiard ball sized spheres. Inside these spheres, there are tiny kernels, as you can see here, of uranium dioxide, and each one of those looks sort of like a jawbreaker. It has layers around it, and then each of these is embedded within this, as I say, this billiard ball sized fuel sphere. There will be a large bucket of these, sort of like a ball pit that you probably shouldn't play in. And over time, as the fuel is spent from these, a robotic arm will pull them out and drop them and send them on their way. The advantage of this technology is that the fuel can only get so hot. Because these fuel kernels can never come into direct contact with one another, and there's space in between them, and then due to the nature of the spherical shapes of these billiard balls, there's space in between them there, so that even if there's a runaway reaction, the temperature can only get up to 1600 degrees rather than 2000 degrees, which is where these would all melt down. And so it's considered by many engineers to be a safer technology. Dropping these spheres into a hopper, basically, and then plucking them out seems less dangerous than having uranium rods dipped into water bath. So anyway, story number 4. And I will spare you the photo at the top of this. It's a mosquito. Scientists have found out something very interesting about the malaria parasite. So they thought they would look into how Plasmodium falciparum affects the mosquitoes that carry the disease. So we know the effects that malaria has on humans, but the mosquitoes that carry it are also affected by it. What's the effect on them, and possibly what's the benefit to the mosquitoes of carrying this parasite? And they discovered there are enormous benefits to the mosquitoes. The infected mosquitoes' sense of smell was significantly enhanced, improving their ability to find hosts. And the messenger RNA transcript profile of infected mosquitoes resembled that of much younger insects. They revealed a physiology that had all the hallmarks of younger animals, more focused on reproduction, more robust immunologically, and generally fitter than their uninfected, middle-aged control siblings. So there's an adaptive advantage to keeping malaria pathogens in the population. That's amazing. It's unfortunate for us, but it is interesting. Finally, story number 5. What Ingenuity and Perseverance have discovered on Mars so far. So 9 months ago, the Perseverance lander landed on Mars, along with its little helicopter friend, Ingenuity, and they've been measuring and examining the Martian soil and surface ever since. One piece of imaging tech on Perseverance is the Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals, or Sherlock. And of course, along with this spectrometer instrument, They, of course, needed a camera, a wide-angle camera, a wide-angle terrestrial scanning something, the Watson. It's using subsurface radar imaging, so it can look through the soil up to 10 meters. And they've found that there's clay at the bottom of the crater that it's in, and thus confirming that it must have been a lake. So where Perseverance is right now must have been a lake at some point. Perseverance weighs a metric ton, so something like 2,200 pounds, and carries its own lab. This piece goes into quite a bit of detail about the instruments on Perseverance and how they're made, and so on. Something really interesting here is that the Ingenuity drone is flying in an atmosphere that's only a bit over 1% the density of Earth's atmosphere. So even at 40,000 feet, the Earth's atmosphere is 30 times denser than the Martian atmosphere at ground level. So they had to design the blades of this little helicopter to deal with that thin atmosphere, and it's successful. Here it is, taking off and flying. It's in the upper left, and it's about to go to the right. There it goes. That's it. And then they've given it 3D cameras so that it doesn't run into any rocks. And here's a map showing where some of the landers have landed on Mars over time. Viking 2, Pathfinder, Opportunity, Spirit, and so on. Because of how it aced its initial objectives, Ingenuity's documentary mission got an extension in 2021. The rover's samples, including rock cores it has already collected, will be stored in caches on Mars. A future Mars mission in cooperation with the European Space Agency will eventually retrieve them. And there you go. Thank you for joining me. I hope you enjoyed it. Please leave a comment, a like, subscribe, and all of that stuff. And I will see you next time.